For this video, we're going to be talking about segments of secants and tangents theorem and applying that theorem to find different lengths. So this theorem tells us that if a secant segment and a tangent segment share an endpoint outside a circle, and we see that here, I have my secant segment AC and my tangent segment AD, and they both intersect at A. This theorem tells us that then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So if I'm looking at this diagram right here, the equation that we get from this theorem is that my tangent segment AD squared is equal to the product of my external segment, which here is this segment in red, which is AB, times my secant segment, which is this entire segment AC. So let's look at problem number 1. I want to find the length of RS, or in other words, I want to find the value of x. Now what this is telling us is that the tangent segment squared is equal to the external segment times the secant segment. Well, my tangent segment is RQ, so that means I'm going to have RQ squared is equal to my external segment, which is RS, times my secant segment, which is this entire segment here, which is RT. Well, RQ I see is 16, so I have 16 squared is equal to RS, which is x, times RT, which is both of these added together, because RT is this entire segment, so to find the length of that, it's going to be x plus 8. And then simplifying from there, 16 squared, I get 256 is equal to x times x, which is x squared, plus x times 8, which is 8x. Now again, I see here that I do have an x squared. That means that this is a quadratic function. So to solve this, I'm going to use the quadratic formula. But in order to use the quadratic formula, I need it set equal to 0. So I'm going to need to move this 256 to the other side first. So I have 0 is equal to x squared plus 8x minus 256. And now I'm going to use the quadratic formula from here. And so I see that a is equal to 1, b is equal to 8, and c is equal to negative 256. So that means that x is equal to opposite of b, so negative 8, plus or minus the square root of 8 squared, minus 4 times a, which is 1, times c, which is negative 256. All over 2 times a, which is 1. I like to go ahead and first simplify under the radical. And so I know 8 squared is 64. Negative 4 times 1 times negative 256, I get 1024. So 1024 plus 64, I get 1088. So I have negative 8 plus or minus square root of 1088 all over 2. And since I only want the positive solution because a length can't be negative, that means I'm only wanting the negative 8 plus square root of 1088 over 2. And when you put that in your calculator, you should get that x is approximately 12.49. Okay, let's try another one. So here I want to find the value of x. Again, I know from my theorem that my tangent segment squared is equal to my external segment times my secant segment. Here my tangent segment is x, so I have x squared is equal to my external segment here, which is 1, times my secant segment, which is 3 plus 1. Well, 3 plus 1, I get 4. 1 times 4, I get 4. And then here I have x squared equals 4. To get rid of that x squared, I can just take the square root on both sides. This time I can do that because I don't have that x term like I had on number 1. And so when I take the square root, I get that x is equal to 2. Okay, trying one last problem. I want to find the value of x. I see I have a tangent segment and a secant segment, so I know I'm going to use this theorem here. And that told me that my tangent segment squared, so 7 squared, is equal to my external segment, which here is 5, times my secant segment, which is 5 plus x. 7 squared, I get 49. It's equal to 5 times 5, which is 25, plus 5 times x, which is 5x. Subtract 25 from both sides. And I get that 24 is equal to 5x. And then divide both sides by 5. And I get that x is equal to 4.8.